Hello everyone, welcome to Gate Academy. How are you all? यस मैं बढ़िया हूँ. आप कैसे हो सब लोग? ओके पहले बताओ ऑडियो वीडियो क्लियर है कि नहीं? प्लीज टेल मी माय ऑडियो वीडियो आर क्लियर और नॉट. इफ यू हैव एनी इशू प्लीज मेंशन इन द कमेंट बॉक्स. आई विल मेक इट करेक्ट. अभी आ रहा है आवाज? यस थैंक यू वेरी मच. ओके भरत गेट का फुल कोर्स होगा इस चैनल में. So I will complete syllabus. You don't worry about that. This is the only first class. Okay. Okay. So आज मैं डिस्कस करूँगा ए ट्रांसफॉर्मर्स फीचर्स एप्लीकेशन एंड नेम प्लेट डिटेल्स ऑफ द ट्रांसफॉर्मर्स. इसमें है ना चैप्टर 1 ट्रांसफॉर्मर्स. द पार्ट 1 इज अ सिंगल फेज ट्रांसफॉर्मर. द आज का टॉपिक क्या है? ट्रांसफॉर्मर्स फीचर्स एप्लीकेशन एंड नेम प्लेट डिटेल्स ऑफ द ट्रांसफॉर्मर. सो ये टॉपिक से पहले हम डिस्कस करेंगे क्या सिलेबस है, द चैप्टर्स क्या है और कितना मार्क्स है गेट के लिए, और सब कुछ हम डिस्कस करेंगे पहले. सो पहले सिलेबस देखेंगे. ईयर what is the syllabus is the given for the gate point of view. The first one is a single phase transformers. द सिंगल पेज ट्रांसफॉर्मर्स में सब टॉपिक्स क्या है? एक इक्विवेलेंट सर्किट, फेजर डायग्राम्स, ओपन सर्किट एंड शॉर्ट सर्किट टेस्ट, रेगुलेशन, एफिशिएंसी. ओके दिस द थ्री पेज ट्रांसफॉर्मर, कनेक्शंस, पैरेलल ऑपरेशन एंड ऑटो ट्रांसफॉर्मर्स पार्ट. ओके दिस इज द सिलेबस इन केस ऑफ द सिंगल पेज ट्रांसफॉर्मर. एंड नेक्स्ट टॉपिक, द नेक्स्ट चैप्टर इज ए डीसी मशीन. सो डीसी मशीन्स में सब टॉपिक्स क्या है? एक सेपरेट एक्साइटेड मोटर्स एंड सेपरेट एक्साइटेड जनरेटर्स, दैट इज अ मोटरिंग मोड एंड जनरेटिंग मोड ऑफ ऑपरेशन एंड देयर कैरेक्टरिस्टिक्स, स्टार्टिंग एंड स्पीड कंट्रोल ऑफ द डीसी मोटर्स. एंड और एक चैप्टर द थ्री पेज ओके इंडक्शन मशीन्स. ओके थ्री पेज इंडक्शन मोटर्स. द इसमें द सब टॉपिक्स एक प्रिंसिपल ऑफ ऑपरेशन, टाइप्स, परफॉर्मेंस, the torque speed characteristics, no load and block rotor test, equivalent circuit, starting and speed control, okay, and operating principle of the single phase induction motor. So one more chapter in the electrical machine, that is the synchronous machine. the इसमें सब टॉपिक्स क्या दिया था? एक cylindrical rotor and salient pole machine, performance, regulation, parallel operations, okay, and starting synchronous motor characteristics, the in per any type of the motor, so losses, efficiency and calculations of the losses and efficiency. So based on the syllabus of electrical machine, so we have classified into the 4 chapters. One is a the पहला chapter क्या है? एक ट्रांसफार्मर है, the transformer part. सो इसमें द 3 पार्ट्स होता है. एक द सिंगल पेज ट्रांसफॉर्मर्स, द फर्स्ट पार्ट इज ए द सिंगल पेज द ट्रांसफॉर्मर एंड दूसरा है द 3 पेज ट्रांसफॉर्मर एंड तीसरा का पार्ट है ईयर दैट इज ए ऑटो ट्रांसफॉर्मर पार्ट. सो इट इज सिंगल पेज ट्रांसफॉर्मर, 3 पेज ट्रांसफॉर्मर एंड ऑटो ट्रांसफॉर्मर पार्ट. सो दिस आर द चैप्टर 1. सो सिमिलर वे द चैप्टर 2, ओके चैप्टर 2 में हम क्या डिस्कस करने वाला हूं? सो वन इज ए द डीसी दैट इज ए द डीसी मशीन्स. सो इन द डीसी मशीन वी विल डिस्कस अबाउट द डीसी जनरेटर पार्ट and second one is a the DC the motor part. and chapter 3, so that is the induction machine. Okay, AC machine mein, so AC machine, or you can say that it is the induction machine. So induction machine, what are the major parts? Okay, so one is the 3-phase induction motor, and second one single phase induction motor, and third somewhat little bit discussion about the 3-phase induction generators part. This is the chapter 3. So finally chapter 4, so that is the synchronous machine. So in synchronous machine we are going to be discuss, that is the synchronous generator part and also synchronous motor part. So majorly one is a synchronous, the 3-phase, the synchronous generator, and second one is the synchronous motor, and the another part the single phase, the synchronous motor. So that is the reluctance motor and the hysteresis motor. So complete syllabus we have discussed, we have divided into the 4 chapters. One is a transformers, DC machine, induction machine and synchronous machine. So ये syllabus, okay, syllabus में है. So our single phase transformer में क्या सब topics, okay, ये topics है. The topic 1 is a single phase transformer, 3-phase transformer and auto transformer. So क्या सब topics है, we will discuss about the feature, operating principle, construction, ideal transformer, practical transformer. So in practical transformer also we have a 2 cases, okay. So operation of the practical transformer under no load condition, operation of the practical transformer under loaded condition. The similarly the losses, voltage regulation, losses, efficiency, voltage regulation, and also testing of the transformer. The testing में भी 2 important test है, एक open circuit test and दूसरा है short circuit test. And another test also there, that is a polarity test and also Sumner's test, that is a back to back test of transformer. Okay, this part we will discuss. Okay, all of it clear? So after this, next we will discuss about the DC machine part, okay, induction machine and synchronous machine. So reference point of view, I will tell you the 2 books, okay, reference books, okay. So one is a electrical machinery by PS Bhimra, okay, this is the first book. So we can refer any concept in from this book, okay. And second one is a electrical machinery by Nagarath and Kotari, okay, this is also very good for electrical machine. And one more books which was written by the PS Bhimra only, generalized theory of electrical machine, that is also very good book for electrical machine for reference point of view. And questions के लिए, हम questions के लिए क्या करना है, और question चालू करने के लिए the पहले previous year questions, the previous year questions of the gate. So from the 91, okay, 1991 to the till date, okay, till this year. Similarly the previous year questions, okay, of ESE, okay, this is also very important for questions, okay, 1 mark questions you can expect here. And another one is a objective questions of, okay, PS Bhimra, the textbooks, okay, this is also very important question for electrical machines point of view. So this is about the chapters, DC machine chapters, okay, reference books and questions point of view, okay. Now हम डिस्कस करेंगे आज का टॉपिक क्या है. द पहले हम द ट्रांसफॉर्मर्स, ओके, फीचर्स, एप्लीकेशंस एंड नेम प्लेट डिटेल्स. सो फर्स्ट क्वेश्चन इन आवर माइंड, ओके, दैट इज द व्हाट इज मीन बाय ट्रांसफॉर्मर्स, ओके. And after that we will discuss about what are the features of the transformer and what are the applications of the transformer. And next one, what are the nameplate details of the transformer. So this one, so suppose the nameplate details, power rating mentioned on the nameplate details, voltage rating also given on the nameplate details. So sometimes we have a question, so power rating is mentioned in the kVA, why not in kilowatts, okay, this type of the question. So all these questions we will discuss, okay, all type of the question. Good morning all, everyone, good morning. Okay, so the first question is the transformers. Okay, first we will discuss about what is mean by transformers. Okay, what is the transformers part, and after that we will discuss about what are the features of the transformer. So very important for 1 mark point of view, and what are the applications of the transformer, and what are the nameplate details. Okay, nameplate details are designed by the manufacturer during the designing of the transformer. So every part, okay, I will tell you everything. So how do we represent the power rating, voltage rating and frequency rating, okay, and all these points we will discuss in this session. Okay, so we know that, okay, transformer में दो पार्ट्स होता है, एक ट्रांसफार्मर कोर, ओके, द ट्रांसफार्मर कोर, एंड दूसरा है द ट्रांसफार्मर वाइंडिंग. सो ट्रांसफार्मर वाइंडिंग में भी द दो वाइंडिंग्स रहते. सो एक द HV वाइंडिंग ऑफ ट्रांसफार्मर एंड दूसरा ए LV वाइंडिंग ऑफ ट्रांसफार्मर. सो HV वाइंडिंग मतलब क्या है? जो वाइंडिंग ज्यादा नंबर ऑफ टर्न्स है उनको ये वाइंडिंग को कहते हैं हम HV वाइंडिंग ऑफ टर्न्स. दैट मीन्स द वाइंडिंग which has more number of the turns is known as HV winding of the transformer. So the winding which has the less number of the turns is known as LV winding of the transformer. So ट्रांसफार्मर में मेन पार्ट्स क्या है? एक ट्रांसफार्मर कोर एंड ट्रांसफार्मर वाइंडिंग. सो वाइंडिंग में दो वाइंडिंग है, एक HV वाइंडिंग एंड दूसरा है LV वाइंडिंग. सो HV वाइंडिंग मतलब क्या है? जो वाइंडिंग ज्यादा नंबर ऑफ टर्न्स है वो ए वाइंडिंग को हम कहते हैं HV वाइंडिंग. सो जो वाइंडिंग लेस नंबर ऑफ टर्न्स है ए वाइंडिंग को हम कहते हैं ए LV वाइंडिंग ऑफ ट्रांसफार्मर. So during the designing, the transformer is designed with the two windings such as LV winding and HV winding of transformers. All of it clear? So next one, these two windings are placed on the transformer core. So let us draw the transformer core diagram. Thus here all of you. So transformer core. So this is the core, which is made with the silicon steel materials here. So here LV winding or HV winding is placed on the core. Okay, for example, I am placing some number of turns on the limb of the core as shown in the figure, and here also I am placing number of the turns, okay, as shown in the figure like this. Okay, so that is a number of turns are placed on the winding. So this is let us assume it has a HV winding of transformer and LV winding of transformers here. So already I have mentioned that what is the meaning of HV winding? The winding which has more number of the turns is known as HV winding. The winding which has less number of the turns is known as LV winding of transformer. So it is a transformer core. So now we will assume that, okay, this is the circuit 1, okay, primary circuit 1, and it is a circuit 2 here. So what is the mean by transformer part? So now we have a question. So what is the meaning of transformer? So transformer transfers the power. Okay, this transformer transfers power. So next one, the transformer is a static device. Okay, this you can say that the device, and the transformer changes the voltage. Okay, changes voltage and current levels. Okay, this is the current levels here. So now changes the voltage and current. So at what frequency here? At the same frequency. So now we have a questions. Okay, so transformer is a static device, okay, which transfers electrical power from one circuit to another circuit. So at different voltage levels without changing any the frequency. Okay, so now we have a question that, so why it is said to be static device? Why not machine? Okay, इसको ट्रांसफार्मर को क्यों स्टैटिक डिवाइस बोलते और मशीन्स को क्यों नहीं बोलते यार? सो इसलिए एक स्टैटिक डिवाइस मतलब द ट्रांसफार्मर में रोटेटिंग पार्ट्स, ओके, दिस रोटेटिंग पार्ट्स नहीं है. सो ट्रांसफार्मर में the electrical energy converted into the electrical energy only. So that means transformer doesn't have any rotating parts, and second one is it converts electrical energy into the electrical energy only. So but not electromechanical energy conversion equipment. Okay, so the any equipment is said to be as electrical machine. So what are the conditions to be satisfied? The first condition is that it has some rotating parts, and second one, it must be electromechanical energy conversion equipment. But transformer, it doesn't have any rotating parts, and it transfer electrical power into electrical power at different voltage levels. So that's why transformer is treated as the static device. Okay, now which transfers electrical power, so from one circuit to another circuit. Okay, another circuit. And next one, the which changes voltage and current. So by using all these points, I repeat once again, listen. So what is the mean by electrical machine? What is the conditions to be satisfied to say electrical machine? So any equipment is said to be as electrical machine. What are the conditions to be satisfied? The first condition is that it has some rotating parts. Okay, second one is it must be electromechanical energy conversion equipment. Okay, for example, the generator and motors are electrical machine, but transformer is static device. In case of the generator, so there are some rotating part, and which converts mechanical power into electrical power. So coming to the motor also has some rotating parts in the form of the rotor, so which converts electrical energy into mechanical energy in the form of speed and the torque. So that's why we call the generator and motors are electrical machine, but transformer is the static device. Okay, is that clear everyone? All of you clear? So that how do we define? So हम ट्रांसफॉर्मर को कैसे डिफाइन करते हैं here? So transformer is a definition of the transformer. Transformer is a static device which transfers electrical power from one circuit to another circuit okay, without changing frequency. Okay, so this is the definition of transformers. All of you clear? So कैसे definition क्या है transformer का? Transformer is a static device which transfers electrical power from one circuit to another circuit at same frequency or without changing the frequency. So there is a one question in the interviews, that is why transformer is treated as a static device. What is the reason? The transformer में rotating parts नहीं है, और transformer में electrical energy converted into electrical energy only, but not electromechanical energy conversion equipment. Okay, are we clear about the definition of the transformer? Okay, so now we will discuss about what are the features of the transformers. So the transformer first feature here. Okay, transformer features of transformers. Okay, this part is a very important for 1 mark point of view. Okay, first feature of the transformer is so transformer, okay, as already I mentioned that द ट्रांसफार्मर में दो वाइंडिंग होता है, एक एचवी वाइंडिंग एंड दूसरा है एलवी वाइंडिंग. सो नाउ दैट मीन्स ट्रांसफार्मर द इज डिजाइन विद द टू वाइंडिंग्स. ओके, दिस द डिजाइन द विथ the two windings. So what are the windings? One is a LV winding of transformer and second one is HV winding of transformer. So what is the meaning of LV winding and what is the meaning of HV winding? So LV winding means the winding which has less number of the turns, okay, and HV winding means the winding which has the more number of the turns is known as HV winding of transformer. So during operation of the transformer, okay, this is the designing, at the time of the designing, so these two windings are LV winding and HV winding. So during operation of the transformer, okay, during operation of transformers, so these two windings are treated as, operation मतलब क्या है, working condition में. So during the working of the transformer, so these two windings are treated as the primary winding and the secondary winding of transformer. So now we have a question, what is the meaning of primary winding and what is the meaning of the secondary winding? So the winding which is connected to the supply, okay, this is a supply, is known as primary winding. So what is the meaning of secondary winding? The winding which is connected to the load, okay, is known as the secondary winding of transformer. Suppose in this diagram, so here we have the two windings, right? So this winding, for example, it has a number of turns 200. So इसका turns कितने हैं, 100 number of the turns. So A winding supply को मैं connect किया था, okay, here AC supply, okay, single phase AC supply को connect किया. So इसको हम बोलते a primary winding of transformers, okay. So the winding which is connected to the supply is known as primary winding. The similarly, so this is the LV winding, so which is connected to the load, so then it is called it is treated as the secondary winding of transformers. All of it clear? So what is the meaning of primary winding and what is the meaning of secondary winding, and also HV winding and LV winding of transformer. So now the first feature of the transformer is the transformer is designed with the two windings. One is a LV winding and HV winding. But during operation, that means whenever we are operating the transformer, so these two are treated as the primary winding and secondary winding of transformer. So what is the meaning of primary winding? The winding which is connected to the supply is known as primary winding. The winding which is connected to the load is known as secondary winding of transformers. Okay. So next one. So these two windings are, okay, next feature of the transformer is a windings. So these two windings are placed on the core, but these two windings are electrically isolated and magnetically coupled through the plugs. That means there is no electrical connection between the primary winding and the secondary winding of transformer. Only magnetically coupled. Okay, this one is the electrically winding of transformer. Okay, transformer are electrically isolated. Okay, isolated and magnetically coupled through the plugs. Okay, so what it means? Okay, this magnetically coupled the through plugs, okay, value. So this, there is no electrical connection between the primary winding and secondary winding, but magnetically coupled to the plugs. Okay, so next feature of the transformer, so that one is the transformer is the single excited device. Okay, excited the device. So what is the meaning of the single excited device? So हम पहले क्या excitation क्या है? So excitation मतलब giving energy to the winding. Okay, giving energy to the winding to create plugs in the winding is known as a excitation. So any one of the transformer winding. So single excitation means the giving energy to the machine or energy, okay, energy to the machine or energy to winding. okay, winding to create flux. Okay, this is the meaning of the flux, that is the meaning of excitation. Just like a biasing in the electronic device. For example, forward bias, reverse bias. So what is the meaning of forward bias? The giving energy to the device in the forward direction, the giving energy to the device in the reverse direction, that is the reverse bias. Similarly, in the electrical machine terminology, so excitation is nothing but giving energy to the machine to create flux. So that is meaning of excitation. And next feature of, okay, it is any one of the transformer winding. That means the either HV winding or LV winding is excited. That means supply is connected then to create the flux in the transformer. That's why it is treated as the single excited device. Okay, all of it clear? Okay, thank you all, thank you very much. So transformer is excited with a single excited device. And one more feature of the transformer, that is the transformer, okay, is excited with with AC supply only. So my AC supply there, okay, suppose transformer is excited with the AC supply only. So now we have a question, if it is excited with the DC supply, then what will happen? All of it clear? So if it is excited with the DC supply instead of the AC supply, then what will happen here? So now here is अगर the DC supply, okay, DC supply दिया था transformer को, so और क्या होगा here? DC nature of the current passes to the winding, okay, DC nature of the current which create the flux is the DC nature. Okay, according to Faraday's laws of electromagnetic induction, the E is directly proportional to, that is a minus n, the d phi dc by the dt here. So I will tell you, this one is a Faraday's laws of electromagnetic induction. So differentiation of the flux with respect to the time. So now this E is equal to, so differentiation of the constant with respect to the time, so that the E1 is equal to 0. So V1 is equal to 0 means what? It acts as the short circuit. So that means, so if the transformer is excited with the DC supply instead of the AC supply, the primary winding of the transformer, okay, will be burned. So never excite the transformer by using the DC supply. Okay, this is also another feature of the transformers. Okay, and next one, the transformer. Okay, another feature is the transformer is constant, okay, constant power device. Okay, constant power device means the power remains same from the primary winding to the secondary winding. So for example point, the P1 is a power in the primary winding, where P2 is the power in the secondary winding of transformer. So now P1 you can write the V1 I1 is equal to the V2 and the I2. So example point in this case, so 200 volts, okay, 10 amps, so that is equal to, so here is a 400 volts, okay, multiplied by 5 amps. So now in order to maintain the power constant from primary winding to the secondary winding, the voltage and current levels will be changed in the transformer. So that means transformer that changes the power, okay, transformer transfer the power by changing the current and voltage levels. So now this one is the transformer that transfers the power, okay, transfers power, so by changing the voltage and current levels. So that's why it is treated as a constant power device. And one more feature of the transformer, so that is a transformer is a constant, okay, constant, the frequency device. What is the meaning of constant frequency device? The frequencies remain same, from the primary winding induced EMF to the secondary. So that means frequency of the primary induced EMF that is equal to the frequency of the secondary induced EMF. So next feature is a transformer is constant, the flux device, okay, it is also treated as the constant flux device. So now tell me, is it a DC nature of the flux? What is the meaning of constant flux device? Okay, so now tell me what is the meaning of constant flux device. What is the meaning of constant flux device? Is it DC nature of the flux, a DC flux or AC flux? Please answer in the comment. Constant, why transformer is treated as constant flux device? Flux is constant throughout the core. Okay, some topics. Okay सर, आपने कहा था जीरो से स्टार्ट करूंगा. यस, ये जीरो लेवल से ट्रांसफॉर्मर का स्टार्ट करूंगा मैं. ये बेसिक टॉपिक है, इसलिए मैं डेफिनेशन से स्टार्ट किया था ना, प्रिंसिपल से स्टार्ट नहीं किया था, सिर्फ डेफिनेशन स्टार्ट किया था. क्या डेफिनेशन है ट्रांसफॉर्मर का, क्या फीचर्स है, सो क्या एप्लीकेशंस क्या है, ओके, एंड नेम प्लेट डिटेल्स क्या है. मैं कंस्ट्रक्शन से स्टार्ट नहीं किया था, सिर्फ व्हाट इज द डेफिनेशन ऑफ द ट्रांसफॉर्मर्स. ये पहले क्वेश्चन है ना, इसलिए मैं बोला था जीरो से स्टार्ट करूंगा. ओके, एसी नेचर ऑफ द फ्लक्स. ओके, वेरी गुड. AC nature of the flux. Flux does not change with respect to the time. ओके सर, आपका कहा था. ओके विशाल मैं बोला था ना, एक्चुअली ट्रांसफार्मर से बेसिक क्वेश्चन क्या है, व्हाट इज अ मीन बाय ट्रांसफार्मर, इसलिए मैं वहां से स्टार्ट किया था. मैं कंस्ट्रक्शन से स्टार्ट नहीं किया था क्लास. वो कंस्ट्रक्शन, ऑपरेटिंग प्रिंसिपल, वर्किंग कंडीशंस, ओके, ईएमएफ इक्वेशन, वहां से नहीं. दैट सिर्फ डेफिनेशन से और फीचर से और एप्लीकेशन से, और दिस वन इज ए नेम प्लेट डिटेल्स of the transformer. So we don't know what are the nameplate details, how they are designed during the designing. That's why I have mentioned that. Okay, so now what is the meaning of constant flux device? Constant flux device means the flux is a, suppose we know that flux is a phi of t is equal to the phi m the sin omega t. Okay, this is the flux value. So flux produced in the transformer, okay, is a time varying nature of the flux only. So this is the flux is nothing but, suppose here is a the flux definition here, it is the ratio of mmf by the reluctance of the core. So mmf is nothing but number of turns multiplied by magnetizing current reluctance of the core. So now this is a number of turns, magnetizing current you can write, so I nu of t, so that is the Im sin omega t, so divided by reluctance of the core. So this is the n Im divided by reluctance of the core, the sin omega t. So this is called maximum value of the flux, the sin omega t values here. So flux produced in the transformer, okay, this is the time varying nature of the flux, but which is independent of the load current. Okay, its magnitude is the independent of the load current or load variation. That's why it is treated as a constant flux device. So now that means the transformer, okay, in transformer or flux produced in the transformer is a, okay, flux the produced in transformer, okay, in transformer is the flux produced in the transformer is time varying nature, okay, time varying nature, okay, but its magnitude is independent of load current or load variation, okay, load variation. So that's why it is treated as constant flux device. Okay, this is also one of the question in the computer exam, why it is treated as a constant flux device. All of it clear? So next one, another feature of the transformer, eighth one is a, so transformer is treated as, okay, this is a transformer is treated as 180-degree phase shifting device. Okay, transformer is treated as 180-degree phase shifting device. What is the meaning of 180-degree phase shifting device? So that means, suppose here the let V is a, okay, in this case the V is the supply voltage of transformer. So this supply voltage, the which nature of the supply voltage? The AC nature of the supply voltage. So we have taken V is equal to V of t is equal to the Vm sin omega t plus pi by 2 here. Okay, pi. So transformer is a, what is the meaning of I knew 2 here? The magnetizing current. So what is the meaning of magnetizing current? The current required from the source. Okay, this current required from the source to create flux in the transformer is known as magnetizing current. So transformer, this is the pure inductive nature. So that's why this magnetizing current lags applied voltage by the 90 degrees. So therefore you can write, so this I nu of t is equal to, so that is a I maximum the sin omega t. Okay, this sin omega t. So now in this case, okay, I nu of t is equal to Im sin. So next one, and what about phi of t? Already I have calculated. Phi of t is equal to phi m the sin omega t. So now according to Faraday's laws of electromagnetic induction, okay, induction here. So now this is a E is equal to minus n, so d phi of t by the dt. We will discuss this part later. So next session में so एक discuss करूँगा हम एक क्या EMF induced, how does EMF induced in the transformer. So now E is equal to minus n by d pi dt. So by simplification you can get, okay, this EMF is equal to, so here is a E maximum, okay, sin omega t minus, okay, pi by 2 values here. So now let us draw here, okay, initially applied voltage the V1. So now magnetizing current I know, and this is the flux phi 1. So now after 90 degrees time delay E is there. So now what is mean by the transformer is treated as 180-degree phase shifting device. So why it is said to be 180-degree phase shifting device? The phase angle between the applied voltage, okay, this induced EMF, so equal to 180 degrees. Okay, the phase difference between the applied voltage and 180 degree, the applied voltage and induced EMF equal to the 180 degrees. So that means EMF induces in the transformer the lags applied voltage by 180 degrees. So that transformer is treated as the 180-degree phase shifting device. Okay, is that clear? All of it clear? Is that clear? Yusuf Salman, transformer cannot work with the DC supply. If it is excited with the DC supply, what will happen? The DC nature of the current passes through the winding. So when DC current, the DC nature of the current create the DC nature of the flux. What is the EMF equation? The E is directly proportional to d phi by dt. So differentiation of the constant with respect to the time. So that is equal to 0. So EMF induces in the winding will become 0. When E1 is equal to 0 means it is simply act as a short circuit. So a very high amount of the current flows through the winding, which may damage. That's why never excite the transformer by using the DC supply. Have we got it? So next one, another feature of the transformer. So that is a transformer. Okay, this transformer, the is electromagnetic energy conversion equipment. So what is the meaning of and magnetic energy conversion equipment? See here. So we have a core. Okay, this is the transformer core, and the windings are placed on the transformer core. So this is the vertical parts. Okay, these vertical parts we know as the limb of the transformer core, and this is also limb 2. Okay, vertical parts of the transformer core is called the limb, and horizontal parts of the transformer core is known as the yoke. Okay, so windings are placed on the limb. Okay, for example, LV winding, the turns are placed on this limb, and this is the HV winding, turns are placed on the limb. So now which is connected to the supply? Okay, suppose if it is connected to the supply, so what will happen? This is the V1 and it is a I1 current. Okay, and this create the flux phi 1 in the core. Okay, this direction of the flux we will discuss later. So this is not our discussion about the direction of the flux, direction of induced EMF, and everything I will going to be discuss in the next session. And here some amount of the flux present in this core. So now under loaded condition, what will happen? The I2 current flows through the load. So this load terminal voltage with the V2, and here is a V2. So just imagine this is a, okay, this is the one electrical the network. Okay, suppose, so we have taken as this complete one is considered as one electrical network. Okay, like, so now it has a 2 ports. Okay, that is a port 1. So port 1 as the terminals of the V1 and I1. The similarly port 2 also as the terminals of the variables are V2 and I2. So we have a 2 terminals, the 2 port network. So that transformer is treated as, okay, transformer is the 2 port the network. Sometimes we also treated as the transformer is a 2 port network here. So now initially, okay, see here, so this is the electrical energy. Okay, this is the electrical energy, the in the form of the voltage and current. The similarly this is the magnetic energy. So this one is the magnetic energy in the form of the flux, and coming to the here, the electrical energy in the form of voltage and current. So transformer is a electromagnetic energy. Okay, this is the electromagnetic energy, but not electromechanical energy conversion equipment. So transformer which converts electrical energy into the magnetic energy, again magnetic energy converted into electrical energy. So that's why it is treated as the electromagnetic energy conversion equipment, and transformer is a 2 port network. So now if it is considered this is the one electrical network, so transformer is treated as the 2 port network here. So these are all features of the transformers. Okay, all of you clear my point? Okay, so what is the meaning of first transformer part? The transformer is a static device which transfers electrical power from one circuit to another circuit at same frequency. And what are the features of the transformer? So it is a constant power device, constant flux device, constant frequency device. Okay, and next one, the transformer is it is designed with the 2 windings. It is excited with the AC supply. That if it is excited with the DC supply, then what will happen? The EMF induced in the transformer will become 0. So that means never excite the transformer by using the DC supply. Yes or no? Okay. So now we will discuss about what are the applications of the transformer. So see here, so what are the applications? Okay, majorly the transformer used in the electrical circuit or electrical power system that to transfer the power from the sending end to the receiving end of the power system. So that here transformer is mainly used in, the transformer is mainly used, okay, the mainly used in, okay, transmission system and the distribution system, okay, distribution system, that to transfer the power from sending end to the receiving end. So now this is a two transfers, okay, power, transfers power or to change the voltage and current levels here. So now suppose this is the two, the change the voltage and current levels. So now if transformer is used in the transmission system, okay, this transformer, okay, if the transformer is used in the transmission system, so it is treated as, okay, this one is treated as a the power transformers, okay, the transformer is used in the transmission system is known as power transformer. So transformer which is used in the distribution system is known as the distribution transformers. All of it clear? So transformer is treated, mainly used in the electrical power system to transfer the power from the sending end to the receiving end. The transformer which is used in the transmission system is known as power transformer. So transformer which is used in the distribution system is known as the distribution transformers, okay. And next one, the transformer, so is used as, okay, used as the impedance matching device, okay, impedance the matching device, okay, device for transferring maximum power, okay, maximum power through the load or to transfer the maximum power through the load in electronic circuit, electronic and control circuit here. So next one, transformer the used as, okay, coupling device also, okay, this one is a the coupling. So this is a, why it is a coupling, already I mentioned that. So transformer windings are electrically isolated, so that means there is no electrical connection between the primary winding and the secondary winding, but magnetically coupled through the plugs. That's why transformer is used as a the coupling device here. So next one, the transformer the used, okay, used as isolation of the two circuits. So isolation purpose, so isolation of the high frequency or low frequency circuits here, that is isolation transformers, okay. And next feature, next application here, the transformer, okay, used to measure, okay, this one is a to measure the voltage and current levels. So what is the meaning of voltage and current levels? So that means the transformer is used as a to measure the voltage and current levels here. So that means it is a power, that is a PT, okay, potential transformer and current transformers here, okay. These are the applications of the transformers point. The first application, main applications of the transformer here. So it is used in the transmission system to transfer the power from the sending end to the receiving end of the power system. So transformer which is used in the power system, okay, transmission system, so is known as power transformer. The transformer which is used in the distribution system is known as the distribution transformers, okay. So next one, transformer is used as impedance matching device to transfer the maximum amount of power through the load in electronic circuits, okay. And transformer is used as a coupling device also. The transformer is used as isolation purpose, so isolate the two circuits, okay, to isolate the two circuits, okay. So next one, transformer is used to measure the voltage and current, so that is known as the potential transformer and current transformer. So potential transformer measures the voltage, high voltage level, and current transformer measures, okay, that is the CT/PT. We can hear these words in the power system also, the CT and PT. CT in the sense current transformer, PT is the potential transformers, okay. Yes or no? Yes or no? Okay, all of you clear? So next one. So what are the nameplate details of the, so this is also very important, nameplate the details of transformer. Okay, see here, the nameplate details of any electrical machine, okay, not only in the transformer but also any type of electrical machine is mentioned by the manufacturer during the designing or during the designing designer or during the designing of the transformer. So what is the typical example of the nameplate details of single phase transformer? So for example point, okay, per single phase transformer, so which are given like this, the single phase, okay, 50 hertz, okay, the 50 hertz, the 10 kVA, okay, 400 upon, okay, 200 volts, okay, these are the name, okay, this is the 400 volts divided by 200 volts. So and also type of the insulation also given, the type of the insulation use, okay, this is the type of the insulation, that is also nameplate details, one of the nameplate details. And per 3-phase transformer, type of the connection. So in single phase transformer point of view, so what it represents, okay, this is the represent nature of the supply, okay, nature of the supply. And what about the 50 hertz? Okay, 50 hertz is the rated frequency, okay, the frequency of rated frequency of the transformer. And this one is a power rated, okay, that is a rated power, okay, this power is a apparent power, not the active power here, okay, apparent power. So why I will tell you that part, the why it is measured in the kVA, why not in the kilowatts, okay, that part I will tell you. And this one is the voltage, the rating of, so which is always EMF induced in the primary winding, so divided by EMF induced in the secondary winding. So this is the RMS values, okay, RMS values only. So now it is a where E1 is the primary induced EMF, okay, whereas E2 is the secondary, the induced EMF here, okay, this is the all the ratings part. So now power rating, the frequency rating and also voltage ratings, okay. So now we have a question, okay, based on this rating like this. Suppose if transformer, okay, if transformer is the operated, okay, this is the one of the question in the competitive exam, if the transformer is operated by keeping voltage constant, okay, this voltage by keeping voltage constant and frequencies are reduced, okay, and the frequency the is reduced below its rated value, the reduced, okay, below the its rated value, okay, rated value, then the what will happen, okay, what will happen, then what will happen in the transformers, okay, this type of the question in the interviews. So if the transformer is operated by keeping applied voltage constant, okay, applied voltage constant and frequency is reduced below its rated value, then what will happen in the transformers, okay. Now tell me, can anyone can answer this question? If the transformer is operated by keeping voltage constant and frequency is reduced below its rated value, what will happen? Agar transformer 50, for example, the rating is a 50 hertz is there, okay, example point, suppose the transformer is designed, example point I have taken the 50 hertz, okay, the 400 upon 200 volts transformer. So 400 साइड सप्लाई मैं दिया था, सो ये सप्लाई ये इसको बोलते हैं हम सप्लाई वोल्टेज, ओके, V1 इज अ सप्लाई वोल्टेज हियर. सो सप्लाई वोल्टेज कांस्टेंट है, लेकिन फ्रीक्वेंसी ऑपरेटिंग फ्रीक्वेंसी ऑफ द ट्रांसफार्मर सो 50 हर्ट्ज से कम. अब इस अगर द 40 हर्ट्ज फ्रीक्वेंसी ओके दिया था इंस्टेड ऑफ द 50 हर्ट्ज, देन क्या हुआ ट्रांसफार्मर में? Okay, what will happen in the transformer? Instead of the 50 hertz transformer, if the transformer is excited with the 40 hertz instead of the 50 hertz, then what will happen? So this is the question is, the transformer is operated by keeping applied voltage constant, the frequency is reduced below its rated value, then what will happen in the transformer? Okay, so maximum value of the flux increases, causing the transformer core take more amount of magnetizing current, followed by the increased core loss. Okay, flux linkage between the winding is affected, flux change rate will be changed. Okay, any other? You can answer, you can first you can give your answers, then I will clarify it where you did correct or where you did wrong. Iron losses is not constant. Okay, so see here, अगर मैं फ्रीक्वेंसी को क्या किया था 50 हर्ट्ज से 40 हर्ट्ज दिया था ट्रांसफार्मर को, सो इस टाइम पे द क्या चेंजेस आएगा ट्रांसफार्मर में, मैग्नेटाइजिंग करंट क्या होगा और फ्लक्स क्या होगा, फ्लक्स डेंसिटी क्या होगा. So what, suppose there are the many questions based on this concept. So if the transformer is if the transformer, but if the frequency by applying the applied voltage a constant, frequency is reduced below its rated value, the magnetizing current, okay, flux density, flux of the transformer, okay, and what will happen in the magnetizing current. Options are given like the increase, decrease, okay, either increased or decreased, okay, remain same, okay, this type of the options. Okay, so we will discuss what will happen. See, by keeping, okay, as applied voltage V1 the is constant, okay, this is the constant. So next, frequency of the transformer F dash is a less than the F rated value, okay, frequency is a reduced the below its rated value, okay, this one is a the frequency is reduced below its rated value. So for example, the rated value is equal to rated voltage. So now here is a example point, the rated voltage is a 400 and rated frequency is a, so that is a 50 hertz frequency, okay. So instead of at this condition, okay, this is given 400 volts, but this we have taken 40 hertz the instead of the 50 hertz. So then what will happen in the transformers? So what will happen? So during operation of the transformers, okay, during operation of transformer, that means the working condition of the transformer. So flux density of the transformer core, the directly proportional to V1 by F ratio. So where V1 is a applied voltage, so where V1 is nothing but applied voltage of the transformer, the F is a applied frequency, supply the frequency of the transformers, okay. So now what we are doing, so this one is a, the voltage is a constant, okay, frequency is reduced below its rated value. So by keeping voltage constant, frequency is reduced below its rated value, the flux density of the transformer core will be increased, okay, flux density of the transformer core increase. So as a flux density here, so after that what will happen? So increased in the flux density, okay, increase or to increase the flux density. So now this one is a, so we know that the B maximum is equal to the phi maximum by the net cross sectional area. So now B maximum directly proportional to phi maximum. So during operation of the transformer. So to increase the B maximum, okay, this is the to increase the maximum value of the flux density, the phi maximum should be increased, right? The phi maximum should be the increase, okay, this is the question. Pi maximum should be increased. So if the what will happen, okay, in order to increase the pi maximum, so if the pi maximum increases, so then what will happen? See here, so we know that magnetization curve, so magnetization curve drawn between the flux and magnetizing current, okay ma'am. So already mentioned that this is nothing but the flux of the transformer. So it is a magnetizing current. So what is the meaning of magnetizing current? The current required from the source to create the flux is known as magnetizing current. So initially, as magnetizing current, okay, this is as magnetizing current increases, flux is also increases linearly until the core gets saturated, okay, until the core gets saturated. So now this point you can say that, okay, this point is the saturation point, okay, and this point is the operating point of the transformers, okay, operating point 1. So for example, at this condition, the V11 is equal to 400 volts, the F1 is equal to 50 Hertz. We are operating initially. Suppose instead of giving 450 Hertz, so if I give this voltage, okay, suppose if I operate other than the rated frequency, so what will happen here? The transformer core goes into the deep saturation, okay, that means the transformer core goes into the deep. So this operating point will be shifted out. So now this is the operating point 2. So at this condition, V11 is equal to 400 volts and frequency is a 40 Hertz frequency. So now compare here. So this is equal to the phi maximum, okay, phi maximum 1, and this one is a phi maximum 2, okay, phi maximum almost equal to here. So now this is the I nu 1 and this one is a I nu 2 here. So in this region is known as, it is a saturation region, okay, saturation region here. So now what we conclude here, so in order to increase the flux in the saturation region, okay, in order to increase the flux in the saturation region, the transformer core goes into the deep saturation, which demands high magnetizing current in the transformers. All of you clear point? So in order to increase, okay, increase flux in the saturation region, okay, saturation region, okay, transformer core goes into deep saturation, okay, deep saturation, which demands, okay, which demands high magnetizing current of the transformers, okay. It is one of the question in the interviews also. So if the transformer is excited, the transformer is operated by keeping voltage constant, frequency is reduced, then what will happen? Yes, that's correct. All of you clear now? Okay. So here my actually voltage को कांस्टेंट है, फ्रीक्वेंसी रिड्यूस किया था. सो ड्यूरिंग ऑपरेशन में क्या होगा, ए बी मैक्सिमम डायरेक्टली प्रोपोर्शनल टू द V1 बाई एफ रेशो. सो वोल्टेज कांस्टेंट है लेकिन फ्रीक्वेंसी रेटेड फ्रीक्वेंसी डिक्रीज किया. So then in this condition what will happen, maximum flux density of the core will be increased. So this in order to increase, okay, to increase the B maximum, the phi maximum should be increased. So to increase the phi maximum in the saturation region, the transformer core goes into the deep saturation. So deep saturation in the sense, okay, here is a initially if it is operated at rated voltage and rated frequency, so this is a just above the saturation point. So next just above the saturation point, this is the operating point 1. Suppose if it is operated at voltage and less than the rated frequency, so this core this operating point shifted at this point. So now here in order to get this part, in order to produce a flux at this region, how much amount of the current? The rate of rise of the magnetizing current is a more in the saturation region. So here rate of rise of the flux is almost less. So that's why. So in this case, in order to increase the flux in the saturation region, the transformer core goes into the deep saturation, so which demands high magnetizing current from the source. Okay. So this is a undesirable, okay, which is the undesirable in the transformers. Okay. So which is undesirable. All of it clear? So this is the one of the question. Now tell me, any more question do you want to ask? Okay, actually here flux is a, okay, flux in the sense, okay, phi. So it is a ratio of MMF by the reluctancy of the core. Okay, how do we get this relation? We will discuss tomorrow. That is the operating principle, very clear. So that means according to Biot-Savart's law, suppose we know that the H is equal to, okay, so this is the N into I, the length of the core. Okay, it is the equation 1. So it is the Ampere's law. So next one, according to the Biot-Savart's law, B is equal to nu H. So where B is a flux by area, okay, permeability of the core, okay, H is equal to Ni by the length of the core. So now this flux you can write the Ni divided by length of the core, the permeability and area of the core. So this is nothing but MMF, ampere turns. Okay, it is the length and permeability area of the core is the reluctancy of the core. So this relation, okay, we will discuss very clear tomorrow. The next session, everything I will discuss about what is the how do we find out magnitude of the flux, direction of the flux, magnitude of induced EMF, direction of induced EMF. Okay. How do we decide the operating point? Means actually any machine can be designed just above the saturation point. So to get the linear advantages of magnetizing current and linear advantages of magnetizing current and flux. Suppose this is up to this level, the flux is directly proportional to the magnetizing current. So just above this saturation point also the flux is almost linear. So to get the advantages of linear magnetization curve, any electrical machine is just designed just above this saturation point. So now if it is operated other than the rated frequency, that means by keeping applied voltage constant, frequency is reduced to below its rated value. So this operating point shifted, that means, so in order to increase the flux in the saturation region, the transformer core goes into the deep saturation. So that demands very high amount of the current from the source. So that is a per example point. Suppose example point C. So we have a, so that is a, at this condition V1 is equal to 400 volts. Okay, and frequency F, the F is equal to 50 hertz. So now at this condition, the requirement of the magnetizing current, okay, that is equal to 10 amps of the current. So 10 amps of the current to create the flux of the 5 milliwebers, okay, per example 5 milliwebers. Now if it is operated, V is equal to 400 volts and frequency the 40 hertz instead of the 50 hertz. So at this condition, how much amount of the current? Example point. So that is the 100 amps of the current to create the flux here pi 1, the pi 1 2. So that is the 6 milliwebers. So here the how much amount of increment in the flux is only 1 milliwebers, but increment here this is the 10 times. So that means 90 amps of the current is required. So if the transformer is operated at 40 hertz instead of the 50 hertz. So which one is a desirable here? The first condition is a desirable. So that's why transformer must be operated at rated voltage and rated frequency. Okay, about apparent power. Okay, suppose there is another question in this here, that is a question number 2. So that is why transformer power rating is measured in kVA instead of kilowatts. Okay, this is also one more question. Okay, transformer power rating is measured in the kVA instead of the apparent. So kVA in the means, okay, it is the apparent power, right? So next, kW in the sense it is the active power, so why transformer rating measured in the apparent power instead of the active power, or why transformer power rating is measured in the kVA instead of the kilowatts? This is also one of the question. So rating of any electrical machine, okay, not only transformer, the rating of any electrical machine is designed based on the temperature rise. So temperature rise मतलब कितना temperature, that कितना temperature बाहर आ रहा है. So during operation of the transformer, how much temperature rise comes in the transformer during operation, or that is known as a temperature rise. So that's technically we can call the losses of the transformers. So that first point here, this is the rating of any electrical machine. Okay, the electrical machine is designed based on the temperature rise. So based on temperature rise. So what is the meaning of temperature rise? So that means the losses. Okay, it is the losses of the transformers. So what is the meaning of losses here? So where majorly we have two losses. One is a iron loss of transformer. So next, second one is a copper loss of the transformer. So iron loss depends on, okay, this iron loss, okay, depends on the voltage, okay, voltage. So which is measured in the volts, right? So next one, the copper loss depends on the current, okay, which is measured in the amps. So actually here, okay, in this condition, so what will happen? We know that apparent power, active power is equal to, so active power output, so that is equal to, so we can write V2 I2 and the cos theta 2. So V2 is the voltage rating of transformers, I2 is the current rating of transformer. So next, this one is the load power factor of the transformer. So during the designing or during the manufacturing, so then what will happen? Okay, during the designing or manufacturing, so manufacturer doesn't know about the load power factor. Okay, that means the load power factor means it completely depends on the, okay, this depends on the load parameters, not transformer parameters. So all up clear point. So this is depends on the load parameter, not transformer parameter. So now during the designing or manufacturing of the transformer, that is a manufacturer doesn't know about the load power factor. So that he was considered as highest power factor of the load. So what is the highest power factor of the load here? The 1. So if power factor is equal to 1, then what will happen? The remaining this active power will become apparent power. So that's why it is measured in the apparent power instead of the active power. Okay. So now that means, so during the designing, okay, this is the during designing of transformer, so this manufacturer, okay, doesn't know about, okay, about the load power factor, so the is consider highest power factor of the load. So that means, okay, that means the 1. So if power factor, okay, is 1, so then what will happen? So this active power will become, so active power will become apparent powers. apparent power. So which is measured in the which parameters here? Okay, it is a measured in in the kVA or volt ampere, okay, kilovolt amperes or megavolt amperes. Okay, this is the reason. So why transformer rating measured in the kVA instead of the kilovolts? All of you clear? Yes, I will provide the PDF, don't worry. So this is the discussion about what is the mean by transformer, what are the features and what are the applications, and also what are the nameplate details of the transformer. So there are the two questions from the nameplate details, most possibility question. One is if transformer is operated by keeping applied voltage constant, frequency is reduced below its rated value, then what will happen? So next one, the why transformer rating measured in the kVA instead of the kilowatts. Okay, you don't worry about Hindi. I will discuss tomorrow onwards Hindi only. Okay, this is the first basic class, that's why I have started in English, but day by day I will discuss. I am trying to discuss in Hindi only. So I already mentioned that I will discuss in Hindi, but today also I am try to discuss in Hindi, but somewhat difficult at the same time. Actually I am very comfortable in English, so day by day I will improve my Hindi, then I will discuss these classes in Hindi only. Okay, you don't bother about sir is only discussing in Hindi. It's not like that. Definitely whenever I am discussing in English also, definitely I will connect to the students. Why? Because so I will use very simple English. Okay, there is no doubt at all. You can understand my English also. I can't use, I never use any vocabulary in my English. Just the simple English. Okay, normally you can understand easily. And one more thing, day by day, I will also try to speak in Hindi. Try to discuss everything in Hindi. But today is the first class. I am trying, but somewhat difficult difficult at the same time. Okay, you don't bother about only English. Sir is discussing in English only, but not like that. Even I am discussing in English also. Definitely you will connect to me and you will learn the subject. But I promise you that definitely I will discuss this subject in Hindi. I am also trying to discuss this subject in Hindi. अभिषेक कुमार, डेफिनेटली मैं हिंदी में डिस्कस करूंगा कल से. आज भी मैं ट्राई किया था हिंदी में डिस्कस करने के लिए, लेकिन आज पहले क्लास है इसलिए मैं डिस्कस नहीं किया था, ज़्यादा नहीं किया था हिंदी में, कभी कभी यूज़ किया था वर्ड्स. नेक्स्ट क्लास से जरूर मैं हिंदी में डिस्कस करूंगा. इज दैट क्लियर? दीप्तान सर, थैंक यू वेरी मच. दीप्तान सर इन द लाइन, डीपी सर इज इन लाइव. ठीक है, आराम से एक्सप्लेन करूंगा मैं कल से हिंदी में. आज पहले क्लास है ना, इसलिए मैं इंग्लिश यूज़ किया था, हिंदी ज़्यादा नहीं यूज़ किया था, लेकिन मैं बात कर सकता हूँ, समझ सकता हूँ हिंदी, कोई दिक्कत नहीं. सो सब देख रहा है इसलिए थोड़ा मैं इंग्लिश ज़्यादा यूज़ किया था. ठीक है रंजन, हिंदी में एक्सप्लेन करूंगा कल से. ओके, और कुछ सवाल है आपके पास? आप पूछ सकते थे कुछ भी. वेरी गुड दीप. Dipankar Datta mentioned that no issues about language, sir. Very good. Yes, that's correct. To learn the technical subject, there is no issue about language. There is all are technical words. Telugu. Okay. Let's see how many members are in my class. How many members are in Telugu people in my class? If you have more than 50, then I will use definitely Telugu also. Yes, I am from Hyderabad. विश्वजीत वीडियो प्राइवेट मत करेंगे, कोई दिक्कत नहीं, आप ये वीडियो बाद में भी वाच सकते थे अच्छे से. సార్ తెలుగులో చెప్పండి, ఐ కెన్ అండర్స్టాండ్ తెలుగు సార్. వెరీ గుడ్ శుభం సింగ్, తెలుగులో చెప్పండి సార్. ఫర్ తెలుగు స్టూడెంట్స్ యాక్చువల్లీ ఐఎమ్ టీచింగ్ ఎలక్ట్రికల్ మిషన్. మీకు ఎలక్ట్రికల్ మిషన్ గేట్ అకాడమిక్ గ్లోబల్ ఛానల్లో డిస్కస్ చేస్తున్నాను, మీరు అక్కడికి వచ్చి వినొచ్చు క్లాసు. ఎవరైతే మీరు తెలుగు ఇంట్రెస్ట్ ఉన్నారో మీరు అక్కడ గేట్ అకాడమిక్ గ్లోబల్ ఛానల్ విచ్ ఈజ్ ఓన్లీ ఇన్ ఇంగ్లీష్. ఓకే, అండ్ ఆల్సో ఇఫ్ యూ వాంట్ ఐ కెన్ యూజ్ తెలుగు, బట్ హియర్ Hindi and English. Okay, I will share this PDF in my Telegram group. You can join in my Telegram group, you will get it. Okay, you don't need to write anything. ओके मैं बता दूंगा आपको क्या लिखना है, क्या कब लिखना है, एवरीथिंग आई विल टेल यू इन द क्लास. ओके, नो नीड टू अरे, बस जस्ट यू ध्यान से सुनते रहो, मैं बता दूंगा आपको क्या लिखना है और कब लिखना है. एक टॉपिक से, ये पूरा बेसिक टॉपिक से. सो मैं क्या किया था आज, सिर्फ डेफिनेशंस ऑफ ट्रांसफॉर्मर्स, बेसिक डेफिनेशन ऑफ ट्रांसफॉर्मर. सो फीचर्स क्या है, एप्लीकेशंस क्या है, और नेम प्लेट डिटेल्स. ओके, ट्रांसफॉर्मर डिजाइन के बाद नेम प्लेट डिटेल्स क्या है रहते. सो ये डिस्कस किया था सिर्फ बेसिक क्लास. इसमें से 2 क्वेश्चन आएगा, एक द नेम प्लेट डिटेल्स का एक क्वेश्चन आएगा, एक रेटिंग का, पावर रेटिंग का एक क्वेश्चन पूछ सकते थे, और एक क्वेश्चन क्या है, इफ ट्रांसफॉर्मर इज ऑपरेटेड बाय कीपिंग अप्लाइड वोल्टेज, फ्रीक्वेंसी इज reduced below its rated level, then what will happen in the magnetizing current. Okay, flux density and flux of the transformer. Okay, very good, no problem. I can understand. Suppose if you can't understand English also, I will try to explain in Hindi every time. Okay, don't bother about it, please come to my class, that's it. You will learn electrical machine very fulfill, definitely, I promise you that. Okay, Vivek Rawat, very good. No, I will explain English, no issue, that's not an issue, but I will also explain in Hindi for Hindi students, the Hindi student who can't understand English very well. This is the only first class, that's why I am not using very much Hindi, but tomorrow onwards definitely I will use Hindi. I will try to use, I will also improve my Hindi. Telegram link. Okay, I will share this Telegram link in the chat box, you can join. Just wait a minute. Yes. Okay. Yes, I have shared this Telegram link in the chat box. I will share this PDF in my Telegram group, so you can join in the Telegram group and to get a PDF. Yes, Ranjan, PDF available होगा. Okay, thank you all. Thank you very much. We will meet tomorrow. We will and we will discuss about operating principle of the transformer. Okay, in operating principle, I will tell you that what is the operating principle of transformer and also working of the transformer. That means how does EMF induced in the transformer. So that mean here is a there are the 4 questions were very important. How to find out the direction of the how to find out magnitude of the flux. Okay, in the magnetic core. And second one, how to find out the direction of the flux. And third one is how to find out magnitude of induced EMF. How to find out the magnitude of the induced EMF in the primary winding, in the secondary winding. How does EMF induced in a coil? How does EMF induced in the transformer winding? Okay, everything we will discuss tomorrow, and also after that, so we will discuss some problems based on this concept. So like if transformer is excited with a square wave voltage source instead of the sinusoidal, then what will happen? If transformer is excited with a current wave square wave current source, then what will happen in the transformer? Shape of the induced EMF. Okay, this type of question I will going to discuss in the next session. Okay, thank you very much. So thank you all. Bye everyone.